Hello and welcome back. For this video, we're going to talk about the transformations of exponential functions. This is part 1. However, all of our goals are right here, so we're going to apply translations to exponential functions. And then I think in the next video, we're going to be doing dilations, reflections, and then use transformations to identify exponential functions from graphs and write equations from exponential functions. Okay, so the first thing we're going to look at is translations of the exponential functions, and we've got two types here. We've got a vertical translation and we've got a horizontal translation. Now if you look at the first one, vertical, if we have g of x represents b to the x, remember x is the exponent, that's what makes it exponential. If we have a plus some value outside, which we'll call k, then that's a vertical translation. Okay, it's the graph of f of x that equals b of x translated vertically by k. So we want k to be greater than 0, then that is translated up k units. So if we have 2 to the x and we put plus 4, that means the graph of 2 to the x will go up 4 units. And if we have k that's less than 0, then the graph of f of x, let's say f of x is 2x, and then we've got a minus 3, for example, then the 2 to the x will go down 3. Now they say translated the absolute value of k units down. Of course, the absolute value of -3 is 3, but 3 units down. When we get to horizontal, we have to think opposite, but you also notice that we're using the letter h here. We're not using the letter k, and also notice that the action of the h is on the exponent itself. Okay, so it's b to the x minus h, and that's the graph of f of x equals b of x translated horizontally. Now again, if h is greater than 0, then we are translating h units to the right. If we have, let's say, 2 to the x minus 3, we are going to translate 2 to the x 3 units to the right. It's actually the opposite of what you see because the calculation here is always a minus, so putting a positive 3 in there means you're actually translating 3 units to the right. And if k is less than 0, then we're going to translate, let's say, 2x, and I put a plus 4 in there. We're translating 2 to the x 4 units to the left, 4 units left, because the only way to get a plus here is to insert a -4, and minus a negative gives us this positive. So the one way you can remember is just go to the opposite of what you see on the h value there. Okay, so now we're being asked to describe the translation in g of x equals 2x plus 3 as it relates to the graph of f of x equals 2 to the x, which is the parent function. So everything's based off of 2 to the x on this one. So our k value here, it's on the outside, it's plus, so our k value equals 3. So the k value is added to the function after it's evaluated. So we evaluate the function and then we add the 3. So what that means is the k value affects the output values, and if you remember, output values are nothing more than the y values, so that's going to have a vertical effect. Now since 3 is greater than 0, or it shows plus 3, it means f of x, which equals 2x, is going to be translated up 3 units. So f of x was right here, so if we look at the y-intercept there, we got a 1, it moved 1, 2, 3 units up. And of course, this intersection right here, that point also moved 1, 2, 3 units up. And one of the ways to know that it's vertical is it's happening outside of the x value itself. It's not happening directly on the x, it's happening after the whole function has been calculated. One other thing I want you to notice here is the original asymptote was down here at 0, at y equals 0. But the translated one up here for g of x, its translated asymptote is actually up here at y equals 3, and notice how the k value was 3 and the new asymptote is at y equals 3. Alright, let's identify a horizontal translation. So we've got f of x equals 3 to the x, so that's our parent function. And now we're going to do 3 to the x plus 1, that's what it shows right here. Now remember, that normally is 3 to the x minus something, so the only way I can get a minus in there is to put a -1. So even though it shows plus 1, I'm actually inputting a -1, which means we're actually going to translate our graph to the left 1 unit. So if we go to f of x, which is here, we look at the y-intercept, you'll notice the y-intercept moved 1 unit to the left. If I come up to this position, that x, that xy, this one also moved 1 unit to the left. So the whole graph is just moving to the left 1 unit. Okay, so now we're going to attempt to identify the multiple translations. So everything's off the parent function, which is 1/2 to the x, which is a decay function. So the parent function is the f of x right here that goes like that. And based on what we see, we've got an x that's been shifted to the right 2 units, and then the whole thing's been shifted down 4 units. So we have an h value of 2 and a k value of -4. So this is going to be to the right 2 and down 4. So h controls your left and right, and k controls your up and down. So if we find a point on the graph, let's say we find this point right here on f of x. This one's going to move to the right 2. So to the right 2, we're going by 2. So to the right 2 would be over 1, which is 2. And then down 4, 2, 4. So it means we land right back on the graph right there. So you can see it fits there. And another way we could do this is by looking at the y-intercept of the original. And the y-intercept is right here. And if we go to the right 2, which means we're going over 2, which is to here, and then we're going to go down 4. So down 1 is 2, and then another one is 4. So we land on the graph again right there. So this does work to the right 2 and down 4. Okay, so now we want to identify the exponential functions from the graph. This one's implying that it's probably vertical. So we're given the function f of x is 1/4 of x. So f of x is this one right here. So we got a decay function. And then g of x is the transform function down here. So how does f of x become g of x? Well, if we look at the y-intercept right here, it's at 1. It appears to go 1, 2 down. So it looks like we have g of x is going to equal f of x minus 2. Now if we rewrite g of x in terms of f of x, so g of x here, this f of x, remember, was 1/4 raised to the x power, so that would be 1/4 raised to the x minus 2 on the whole thing. All right, so we're going to do it again, only we're going to try and identify the horizontal. Now the parent function again is just 2 to the x, which is this problem right here. And then how does g of x change? Well, if we look again at the y-intercept, the y-intercept appears to have moved 1, 2, 3 units to the right. That would be g of x is going to equal to f of x minus 3. So what that means, as we go to write g of x, this minus 3 here on the x is going to be on the exponent itself, because this is all happening directly to the x value. So this is going to equal 2 to the x minus 3. This number in here is actually our h value, not our k value. So the h value subtracts from the exponent. Now, if this was a movement to the left, if I'd gone left 1, 2, 3, I would have input x minus -3, and that would have given me a +3, or x plus 3.